evaluating expressions. Yay! Writing and evaluating expressions. So first, let's talk about the whole writing. Let's talk about how to write a numerical expression. All right. And now we'll do our definition about algebraic expression. Algebraic expression is a type of math expression that has at least one variable and at least one operation. At least one variable and at least one operation. Y'all are bleeding me out of pencils. I prefer the pre-sharpened pencils if possible. You're gonna have to sharpen it. Yeah, if y'all just want to just buy pencils and just bring them to me to store for you. What? I like it. All right, so an algebraic expression. You notice that it says expression and not equation. An equation has an equal sign. An expression has no equal sign. So it means that group of letters and numbers, it doesn't equal anything, okay? I mean, it's going to equal something. It's going to have an answer, but it doesn't start with an answer. I don't know where I was going with that. All right. What? So an algebraic expression is a type of math expression that has at least one variable and at least one operation. All right? Let's talk about the different parts of an expression. So what you're looking at up here is an expression. You have okay, so the overall altogether you have an expression. Then you have these two groups right here. So you have everything in front of your operation and everything behind your operation. These are called terms. Terms are separated by operations, okay? So terms are separated by operations. So if I wanted to identify how many terms I had in this expression, I would say 2, because I have one group in front of the plus sign and one group behind the plus sign. Does that make sense? Yeah. Okay. Now, let's take a look at my first term. In my first term, I have a coefficient and a variable. A coefficient is a number in front of a variable. It's a number attached to a variable. Then you have your variable. A variable is any letter in the alphabet. The most common variable you'll probably see is X. They really like X as a variable. That's why, remember how I talk about that we don't really do the X for multiplication anymore. We want to kind of do the dot. That's why, because now that we're introducing variables, the most common variable that they like is X. So if you have X variable, if you have like, oops, sorry guys, 4 times X, you see how that can get, oh, give it a second, it'll pop up. Do you see how you have 4 times X? That can get a little confusing, right? What? Yeah, so that's why we really kind of want to start doing our dot for multiplication. But anyways, that wasn't even what part of the lesson was about. So the coefficient is the number attached to the variable, and the variable is your letter. Now, do you know, let's see if anyone knows this, bonus question, does anyone know what operation is happening between the 4 and the M? What operation do you think is happening between the 4 and the M? Let's see, cash. No, but there's an operation going on. It's an invisible operation, an operation you can't see, but there's an operation between that number, that coefficient, and that variable. Bella? Not division. Bryn? Not quite an exponent. Peyton? Multiplication. I feel like that's how we were just going around guessing. But multiply. Anytime you have a coefficient next to a variable and there's no operation, like 4m, that means that you're going to multiply 4 by whatever m is. Does that make sense? We good? Yes? It's a little confusing, but you just have to know that anytime you have a coefficient next to a variable, it's telling you to multiply. It's lazy. They lazy. They don't want to write the multiplication sign. All right, and then the second term, just a regular number all by itself with no variable is what we call a constant, okay? Let's take a look and let's see if we can identify some numbers in this phrase. So I have this expression, 3r minus 4. Who can tell me by raising their hand, what is my coefficient? What is my coefficient? Olivia? 3, good. Remember, your coefficient is the number in front of the variable. Who can tell me what my variable is? Aubrey? R, good. Remember, your variable is your letter. And what is my constant? What is my constant, Maddie? 4. Remember, your constant is just any number that's all by itself. All right, bonus question time. How many terms are in this expression? How many terms? Show me with your fingers if you know. How many terms are in this expression? All right, y'all so smart. So this right here is 1 term. This right here is 2 terms. Remember, terms are the numbers or coefficient variables. They're the things that are separated by the operations. All right, let's look at another one. Tricky one. Who can tell me in 4c plus 1/2, what is my coefficient? Let's go to Derek. 4, good. 4 is my coefficient. What is my variable? What is my variable, Kennedy? C. See that right there? You were right. You see what I did there? What is my constant? What is my constant, Cameron? 1/2. Good. Now, with your fingers, bonus round, show me with your fingers or type in the chat, how many terms do I have here? Good. I have 1 term here, 4c, and 2 terms here, 1/2. So 2 terms. 2 terms. Remember, terms are everything separated by the operations, okay? All right, so now that we know about an expression and we know the parts of an expression, let's talk about our operations. Let's talk operations. Now, hopefully we all know that there are various words out there that mean different operations. So, for instance, if I read something in regular words, like a word problem, and it wanted me to add, what are some words that would give me a clue that it wants me to add? Emily? Okay, Cameron? Total, that's a good one. What are some more words that are telling me it wants me to add? Carson? Some. What's some more? Eduardo? I'm going to put add/addition, because I feel like someone's about to say add next. Kennedy? All together. Kennedy, you're very smart. I know you were. That's why I said you were very smart. You're the only one to look up there. What are some more, Chloe? Combined. Aubrey. Increased by. What are some more, Aria? Plus. Anyone got another one? Emily? In all. Cash. Make. And Miss Shelley ran out of room. But there are tons and tons more that we didn't even cover. Okay, what are some words that could tell me to subtract? Subtract. Olivia? Difference. Online people, please feel free to type some out in the chat. You don't have to be so quiet. Kaden. Decrease by. That's a good one. Maddie. We're going to save lesson for a minute. I'll show you why. But good job. That's just a different one. Cameron. That's for addition, and we're going to save that one. Levi. What? Gave. If I gave Peyton some cookies, I got to subtract from my amount of cookies. Chloe. How much more? All right, Olivia. Subtract. I don't know why. That one always usually goes first. Aria. Take away. Kennedy. Remains. Emily. Shared. Cash, you got one more? What? I can't hear you. Fewer. All right, now let's try multiplication. What are some good multiplications? Kaden. Multiply. Carson. Times. Eduardo. Area. Aubrey. Product. Kennedy. Triple. You're so smart. It's almost like you're looking at a sign. Camden. What? Quintuple. I don't know if I feel like I did not spell this right, but we're just going to say I did. Chloe. We're just going to keep that with multiply. Same. Levi. What? Each. Peyton. Double. Olivia. Groups of. Emily. All together. Yeah, try not to look up there for dividing. Levi. Divisor. Cameron. Quotient. Kaden. Ratio. Yes, son. I'm proud of you for that one. Peyton. Split. Did you look up there? Yes, girl. Aria. What? Cut up. That's a good one. Yes. Quotient. It's already on there. Aubrey. Dividend. Emily. Per. Brand. Divided. Cash. Kennedy. Percent. Share. Between. All right. Now, let's talk about this little flippy arrow thingy. This flippy arrow thing. This is, I think, the hardest thing about writing expressions. This little flippy arrow thing, okay? A flippy arrow thing. This has no name. This is Miss Shelley's own invention. So I can call it whatever I want. And I call it a flippy arrow thing. The flippy arrow thing is what Maddie said earlier. Maddie gave us an example of the flippy arrow thing when she said less than. Another one would be greater than. More than. It's divided by than? I don't think that's one. No, divide doesn't have a than. Okay. So these than words are telling me that I'm going to switch the order. So in all my other operations, in all my other columns, my addition, subtraction, multiplication, and division, I'm going to write the numbers in the order that the problem gives it to me in, okay? But anytime I have this little than word, I got to do my little flippy thingy. Wait, what did I call it? I already forgot. My flippy arrow thing? Is that what I called it? Flippy arrow thing. So anytime I have than, this stupid word right here is going to make me do my flippy arrow thing. So that means if I had something like, say I had 7 less than X, I have to do this flippy arrow thing, and I'm going to write the numbers in opposite order. So instead of my 7 minus X, I actually would have to do X minus 7. So my little flippy arrow thing flips the order of the numbers. Does that make sense? We're going to do some problems, so hopefully it'll help. Okay? Flippy arrow thing. Don't forget it. All right, so let's look at some problems, okay? Now, have you talked about annotating text? Please stop. In Ms. Conley's class? Good, because in order to do these problems, you kind of want to annotate text, okay? So this is what I do. Anytime I have a number, I draw a box around it. Anytime I have an operation, I draw a circle around it. So let's do that. 6. 6 is a number, so I'm going to draw a box around it. 6 times the quotient of 4 and a number. 4 is also a number, right? Do I have any other numbers in here? Okay, trick question. Madeline said it. I have the what? The word number. The word number right there is a variable. Okay, that a number is a way to say variable. And I'm just going to make it variable n because number starts with n. What words do you see in here that might represent an operation? Carson? Quotient, good. Are there any other words, Caden? Times. All right. So now what I'm going to do is I'm just going to write this out exactly as it is. Because do I have the word than in it? No, there's no than in this in it, so I can just write it in the order. So I'm just going to do 6 times, what does quotient tell me to do? Times tells me to multiply, quotient tells me to divide. So I'm going to do 6 times divide 4 and a number. Or I could have also written it as 6 times 4 divided by n. I can show division using a fraction because a fraction also tells me to divide. So either or. And that's your final answer. Yeah, we're not solving it. We don't know what it's equal to. We can't solve it. We're just writing it out in numbers. Yes. For what? I did. So, hey, excuse me. You are not talking. That's it. That fraction right there, you see how I put the fraction bar? That's the same thing as divide. The fraction bar tells me to divide. So instead of writing out a division sign like I did in the second problem, I can use a fraction bar, and that fraction bar tells me I have to divide 4 and n. So another way you write division is with a fraction bar. Yes, Eduardo. I'm already recording. All right, so now let's take a look at another example. Let's take a look at a number decreased by 13. So let's start with identifying my numbers. What are my numbers, Peyton? Give me one. 13 is a number. I'm going to put a box around 13. What is another number, Camden? Number. Number, it doesn't tell me what number, so that means it's going to be a variable. We'll make it n for number. You want to make it x? All right, we'll make it x. All right, what operation? Do we see an operation, Aria? Decrease, and it means to subtract. Good. So all I have to do is just write the numbers in order. So x minus 13. The n. What do we? That's not too bad, right? If you use your skills you learned in Ms. Conley's class to annotate, these problems are really easy. So, we all good to move on? All right, last one, I believe, right? All right, 11 less than 3 times a number. Before we do anything, let's identify numbers. I need some numbers. Who can tell me some numbers? Carson? Number. What do we want number to represent? Z. X. I heard X. I'm sorry. Z looks like a 2. You have to be careful. Don't use Z. Kennedy. 11. Good. Where's another number? Eduardo. 3. Oh, man. All right. What about some operations? Who can tell me some operations in this problem? Some operations. Madeline. Les. What does Les tell me to do? Oh, no. What do we see? A flippy arrow thingy. And I annotate my flippy arrow thingy just like that. Okay, what other operations do I see, Cameron? Times. Okay, so remember what that means is we're going to look at everything past the word than, and that is what we're going to write first, okay? Because I have a flippy arrow thing, I'm going to go after the word than, and everything after goes first. Everything before goes after. Good? We okay on that? So that means that I'm going to start with 3 times a number. So I can do 3 times a number less than 11. I also another way you could write this, I could do 3x minus 11. Because anytime I have a coefficient next to a variable with no operation, I'm multiplying. It's a number. A number we do not know yet. And we cannot solve until either they tell us what x is or we have an equal a number. You gotta stop. All right. How are we feeling on this? Pretty okay? Good, good. All right. So let's talk about how to evaluate these expressions. How do we evaluate these expressions? Levi, wake up. To evaluate an algebraic expression, we're going to use substitution to replace the variable with the number. Where do you think you might see substitution at in real life? Where do you think you might see, like, a real-world example? Levi, copy the notes, please, of substitution. Cash? And what? I can't hear you. I'm sorry. In business? Okay, yeah. For instance, I like to do Walmart click list a lot. And that means, like, I'll order online, and they'll shop for me, and I just have to swing by and pick it up. Sometimes, though, I'll order something online that may not be in store and it hasn't updated yet. So they'll pick a similar item and give it to me instead. Does that make sense? Where's something else you see substitution? All my sports players should have their hands up. Kaden? When you swap one player for another. That was the main one I wanted because all substitution is switching out my variable for a number. Okay, Camden had said he has another one. Okay.
Sometimes you have to swap out different skills.
Swap out different skills? Yeah, that's a good one. Eduardo? Teachers, yeah, if I'm going to be out one day, you're going to substitute me out and put a substitute in. That's literally the definition of a substitute, to replace a teacher. That's a good one. All right, Bella, last one. Workers, same thing as teachers. All right, so let's talk about this. Let's look at this expression, 4m minus 3. To evaluate this, to solve this expression, all I'm going to do is substitute. I'm going to take out m, and I'm going to sub in my 5. Okay? So, because it tells me right here, it tells me in the problem m equals 5. So, what operation, though, is happening between that 4 and that m, Levi? Yes, good. Multiply. So, I'm going to do 4 times 5 minus 3. 4 times 5 minus 3. What should I do first? Should I do 4 times 5 or should I do 5 minus 3? Why should I do 4 times 5? Because, not quite because it comes first. Peyton, PANDAS, what we talked about last class, mic drop. I probably shouldn't do that. Should not mic drop the Apple Pen. So that means I'm going to do order of operations, PANDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, then addition, subtraction. What is 4 times 5? 20. Bring down my minus 3. And finally, I can do 20 minus 3, which is? Good job, Kaden. Shouted it out early. This isn't that bad, right? No, substituting isn't that hard. All right. Oh, I see a couple of people still copying this. I feel like a couple of you, though, sometimes aren't copying what's on the board. You're, like, moving on to the next examples. Yeah, I thought so. All right, let's look at this problem. N plus 15, where n equals 4. So that means what am I going to do? Someone tell me what to do. Someone tell me what to do. Someone tell me what to do. Aubrey. Look at what n equals. 4. So substitute this 4 in for n. That would be 4 plus 15. And class, what is 4 plus 15? 19. Final answer. We can go home now. I'm just kidding. I wish I could. When I said that on recording too. Your parents are going to be like, wait, what? All right, let's look at another one. Ooh, we're getting a little harder now. Well, there we are. 3 plus parentheses 12n. 3 plus parentheses 12n. What should I do first, Levi? You want to phone a friend? All right, Levi's going to phone Camden, because if not, Camden's arm may literally shoot off his body. Yes, I need to sub in my numbers. I'm going to sub in 4 for n. What operation, though, is happening between 12 and n, Cameron? Peyton. Multiplication. Anytime I have a number next to a variable, my coefficient next to my variable without an operation, it is. Thank you. I was hoping someone would say it. So that means I have 3 plus parentheses 12 times 4 close parentheses. What should I do first, Eduardo? Do what's in the parentheses because, please excuse my dear Aunt Sally, please parentheses. Oh, my Aunt Shelly, sorry. What is 12 times 4, everyone? 48. So now I am going to drop my 3 and my plus like they're hot, and I have 3 plus 48. What is the last thing I do, Bren? Add. What is 3 plus 48, everyone? Final answer is 51. We should all be copying this. Do we all copy? Why? Now that I came up with by myself. The drop it like it's hot is 100% all Nelly. All right. Are we ready to try a little bit harder of a problem? Yes. Do we want to try this problem ourselves? Yes. All right. This is what I want. I'm going to give you 2 minutes. 2 minutes. I want you to solve this on your paper. 2 minutes. Solve it on your paper. Come on. You got this. I believe in you. Michelle is doing math. Hold, please. Hush your mouth. All right. Are we ready? All right. Just another, 30 more seconds. 30 more seconds. Yes. Lunch is in 8 minutes. We're almost done. We may finish before lunch. All right, I'm going to show you the answer. I hope you all got the answer of 18. I'll do a little cheerleading seat clap. Yay, good job, yay. All right, okay, there's the other type of problem that you may find. Oh, no, on your paper, does it say B2 or B squared? B squared. Okay, my computer messed up. This should actually say, guys, I need you to stop talking. Look at that box on there that says pens, erasers, and sharpeners. What is another way you can say b to the power of 2? B squared. Yes. B here or B squared. Stop talking or B squared. All right, so let's solve this. This is another way that you may see problems, and it's the same thing we have been doing, just more words. This one says if b equals 6, solve b squared minus 7. So all I'm going to do is the exact same thing I have been doing, and that is just substitution. So instead of b, I'm going to put 6 squared minus 7. What does my Aunt Sally tell me to do first? Parentheses? Do I have any parentheses? No. What else does my Aunt Sally tell me? Or Aunt Shelley? Exponents. Do I have any exponents? Yeah. Yes, I do. What is 6 squared? 36. Remember, 6 squared tells me to do 6 2 times. So that would be 36 minus 7, which is, Eduardo, 29. So what do we think? We like this lesson? Not too shabby?
Actually, it's the best lesson ever. I love it.
Thank you. Good. Yeah. You were on a roll till you took that mask off. All right, let's do another one. Oh, this one's a little tricky, but I promise it's not. All right, this now is just 3 variables, 3 different variables. So all you're going to do is plug in the 3 different variables. Guys, please stop. We are almost done with this lesson. So all we have to do now is take and we're going to plug in each variable amount. So what does that 3z, what operation is between 3 and z? What operation is between 3 and z? Who can tell me, Mark? Multiplication. All right, so now all I have to do, guys, is just rewrite the problem. So 3 times, what does z equal? 3 times 6 minus, what does y equal? 4 plus, what does x equal? 2. So all I have to do is follow what my Aunt Shelley tells me to do, which would be parentheses. Any parentheses? Exponents. Any exponents? All right, multiplication or division? Yes, what is my multiplication or division? What, everyone, is 3 times 6? 18 minus 4 plus 2 has been dropped like they were hot. Now, what does my Aunt Shelley tell me to do? Add and subtract. What, however, am I going to add and subtract? 18 minus 4 or 4 plus 2? 18 minus 4, because when we do these problems, we do them just like how we read, and we go left to right. So 18 minus 4 is 14 plus 2. So final answer is no. You do them whichever comes first in the problem. So in this problem, the subtraction sign came first, so that's what you do first.